5.3.1c. If h of t equals negative 1 over the square root of t, then h prime of 2 equals... Alright, so whenever we see a square root, remember there's going to be a fraction involved in our exponent. And I also wanted to try to rewrite this function so that I can use my power rule on it. So I'm going to call this negative 1 times t to the power of negative 1/2. The 1/2 from the square root and the negative because it was in the denominator. Now it looks like something I could apply my power rule to. And the power rule said we should do x to the n as n x to the n minus 1. So I'm going to do that. I'm going to pull the negative 1/2 in front, and then I'm just going to subtract 1 from the power. Alright, so I have my negative 1 from the given problem, and then negative 1/2 came in front, and then I multiplied by t to the, when you subtract 1 from negative 1/2, you get negative 3/2. Then I rewrote it, because a negative times a negative is a positive, and then I put the t to the negative 3/2 back into the denominator with a positive 3/2. Now I would not have done that if I were going to take another derivative, like a second derivative or third derivative. But because I'm going to plug in a number now, it's easier to do that with a positive exponent. Okay, so now that I have the derivative, I can plug in a 2. I put a 2 everywhere we see a t. So that gives me 1 over 2 times 2 to the 3/2. Well, 3/2 is an improper fraction. 3/2 is 1.5, right? 1 plus a half. So I can separate the 3/2 into 1 plus 1/2. In other words, our denominator is 2 times 2 to the 1 times 2 to the 1/2. And 2 to the 1 is just 2, right? So 2 times 2 is 4. And then 2 to the 1/2 is the square root of 2. So you can see all the choices, and this one matches choice B.